So today we will do a really fun problem from number theory. The problem says that there are 27 divisors of a number n. So n is a positive integer and there are 27, exactly 27 divisors of it. For example, if you look at the number 6, what are the divisors of 6? They are 1, 2, 3 and 6 itself, right? So 4 divisors are there. 1, 2, 3, 6. The number n in that particular question has 27 divisors. Now the question is, what is the product of the divisors? So that is d1 times d2 up to d27. Of course, the answer will be some expression in n. So some expression in n. It's a very simple but interesting problem. Let's try this together, okay? So the first thing that you have to realize, and this may not be needed directly in the problem, but it's a very important fact from elementary number theory, that if a number has odd divisors, odd number of divisors, then it's a perfect square. Perfect square means it's a number like 16 or it's a number like 36. If and only if a number is a perfect square, it has odd number of divisors. We discussed this and proved this in our Math Olympiad course and ISI CMI entrance course at chinta.com. You can check the link in the description for all the details of the program. But it's not very hard to prove it. So can you try to prove this fact and put it in a comment in the description? So how does that help us? Well, there is another thing that we will be using that's called pairing of divisors. It's very important. Pairing of divisors. This says that if a number d is a divisor of n, then n by d is also a divisor of n. If you think about it, it's not very hard. Let's take an example to understand this. The number 3 is a divisor of 36. So 36 by 3, which is 12 by the way, is also a divisor of 36. Right? So 3 and 12 are pairs. You can think of them as friendly divisors. They come in pairs. The divisors come in pairs. In fact, for 36, I can write down all the pairs. Let's first list out all the divisors. So 1 is a divisor. So 36 by 1 is its pair or friend. 2 is a divisor. So 36 by 2, which is 18, is its pair. 3 is a divisor. That means 12 is its pair, 4 is a divisor, 9 is its pair. And finally, and that's the fun part, 6 and 6. Well, the pair of 6 is 6 itself because 36 is a perfect square. So we have 9 divisors in total. 8 of them come in pairs, and their product, if you multiply them out, their product is always 36. So the same thing applies to our number n. The divisors of n will also come in pairs. So d1 times d27, I'm assuming that the divisors are written in an increasing order. That means d1 is 1 and d27 is n. So d1 times d27 is n. d2 times d26 is also n. d3 times d25 is n, and so on. And at the end of the story, you will have one divisor left out, which is its own pair, because we know this is a perfect square, just like 36. It has odd number of divisors, right? So d4, d24, d5, d23, d6, d27, d22, sorry, d7. You don't need to write down all of them, but I'm just explaining you, and I want you to really understand what's going on. So that's why I am writing it down. So these are pairs of divisors. And each of them multiply to give you n, right? So you see, they are coming closer. And can you guess what will be the middle value? Right? Can you guess that? Yes, you're right. It's d14. So d14 is actually square root of n, because it's or n to the power half. So it's the middle value, and that's just like 6 in this example, right? Okay, so how many of them are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Or you could have divided 27 by 2 and gotten 13. So if you multiply them all out, you will get n to the power 13, because there are 13 such equations, and then 1 n to the power half, right? So this is equal to n to the power something, and I'll give this to you as a challenge question. You can write down the final answer in the comment section. By the way, this month's mock tests on IOQM, ISI, CMI entrance, American Math competition, all of them are out and available. So if you are interested to take them, you can check the link in the description, join us through WhatsApp groups, and request us for access. Thank you for watching this video. I will see you in the next one.